specifically in online advertising. And what the matching problem is concerned with is basically with matching or connecting advertisers and consumers. And I'm sure you've seen this many times and you can imagine what it is. But anyway, a matching would be, as you see the definition here, a subset of edges such that no edge is an end of two or more edges, okay? And a perfect matching would be the case when every node appears in the matching. So let's see this. If you guys see this is called a bipartite graph. And on one end we have 1, 2, 3. Imagine that could be Nike, Adidas, Reebok, and Under Armour, for example. And on the other end we have ABC, and that could be, you know, each person here in the class, for example. 4 different people in the class. So 1, 2, 3, 4. Okay, the company is trying to advertise, and ABC, D would be people searching on the web. So I don't know if you're familiar with Google AdWords, but Google AdWords came after Overture in 2000. They were kind of the creators of the concept, and Google AdWords took it to the next level. But basically the way it works, advertisers bid on search keywords, and bid, what bid means here, means that advertisers set something called the maximum cost per click, and they call this max CPC, okay? But it's saying every time that somebody clicks on this ad that links to my page, I'm gonna pay $1. So let's say you search the word sneakers, relating to the shoes, right? Not the other sneakers, but sneakers. For the shoes, you know, maybe Nike paid, you know, $4 for each click of, you know, every time somebody searched sneakers. Then let's say Reebok paid 3 and Adidas paid 2. So if you search sneakers on Google and you get Nike, then you click, they'll pay $4 to Google. If you don't click, they will not pay, okay? But considering this, and the definitions that we have here, could somebody give me a match considering this bipartite graph? Can you see it well enough? Right here, the 1, 2, 3, 4. Can you see the lines? Yeah. Any volunteer to give me a matching there? Mike?
1A.
Okay. So 1A, and that's one part of the match. If we look at the definition, is a subset of edges such that no node is an edge of 2 or more edges. So you said 1A, which would be this. All right. What else?
1C.
So 1C could not be because,
Oh, I see.
just as you see the definition. So now let's move to 2.
2B.
2B, for example. All right. And the next one?
3D.
3D. Then can you do anything else? So you see in this case now you cannot connect for A, right? Because A is already taken.
Right.
Okay.
3B also, because B is already taken.
Yeah. So this would be, if you all see 1A, okay, here 1A, which would be this line, 2B, and 3D. This is a matching, right? But it's not the perfect matching. Okay? So, do I have that? So if we go to the next slide, here we see the perfect matching for this for this bipartite graph, right? And let me just use this. Okay. So what you just said, Mike, was perfect because what you did basically was the greedy algorithm, which is looking one by one, and you know, just seeing a connection and adding it to the matching. But as we can see, it's not a good solution to find the perfect match. These are some algorithms that are used: the Ford-Fulkerson, the augmenting path, and the Hopcroft algorithms. Those are used to find something called the maximal matching, right? And my question here is, will the maximal matching and the perfect matching always be the same? It's a little bit tricky. I'm making you think here.
Why?
What did you say, sorry?
I said I'm going to say no, but why no?
No, because you can have a maximal matching, but you would have a perfect matching. In this case, let's say we didn't have, I don't know, in this case it's easy because you have 4 and 4, but you know, maybe you have a set amount of companies trying to advertise and a set amount of clients, which will not be matching. Imagine, I don't know, imagine D, which is a person, instead of being interested in Nike shoes, we're interested in Adidas. Then you will have Nike, which is not advertising to anybody. Do you guys get that? Yeah? So getting the perfect matching will be difficult, so most of the companies will strive to find the maximal matching, which hopefully will be close to the perfect matching. All right? Thank you.